Okay, so finally I'm back. Okay, it has been a while because of my busy schedule in my new work. So I really do not have much time to do maths lah. So okay, today we are going to tackle a new Olympia question and let's get into it. Okay, so today this is the question that I'll be tackling. All right. The question, okay, it came from Instagram. So nearing the end of the video, I will show you where I got this question from, and we can double check the solution to this problem. Okay, so this problem is actually asking us what is the definite integral from limits of 0 to 1 of the function of the root of x plus the root of x plus root of x, so on and so forth, to infinity with respect to x equals to. Now we can see over here, this is actually what, if you recall in my previous few videos, I've been mentioning. Okay, something like this, we call it a nested radical. So today we are going to see how are we going to perform antiderivative or known as integral to such a function. All right. Now, okay, here's the solution, how I solve it. Okay, so basically, as usual, the basic technique to solve this, okay, I let this be equals to y. The entire nested radical, I just equate it to something else called y. So in that case, very quickly, what I can establish is I can square both sides of the equation, subtract x on both sides, okay, and I get back what I have over here one more time. So in this case, all right, I will get y squared minus x equals to y, okay, because over here, this entire chunk here equals to y. So, okay, basically I have this, okay, on the right-hand side equals to y. Okay, pretty straightforward. So now what? How am I going to go about? All right. Now I'm going to perform something called the implicit differentiation for a function. So this is implicit functions. I'm going to differentiate both sides of the equation with respect to x. So if I differentiate both sides with respect to x, all right, I have basically this is what I get. Sorry. All right. On the right hand side, okay, because x, if I'm going to differentiate x with respect to x, I get 1. All right, and if I'm going to differentiate with respect to x of y squared, okay, I will get 2y of dy dx. Okay, and to differentiate with respect to x of y, I get simply dy over dx equals to 1. All right, for those of you who understand what is implicit function, you will know what am I trying to demonstrate over here. Okay, over here, this part. Okay, so the next step, okay, I can just group up the terms, okay, shift them all over to the right-hand side, and I get dy dx is equals to 1 over 2y minus 1. Okay, this is very basic implicit function. Okay, the procedure. Okay, very simple and straightforward. So now I can rearrange the term with respect to x on the left-hand side and 2y minus 1, okay, product it with dy on the right-hand side. So now what happens if I'm going to multiply y on both sides of the equation? So I have y times dx is equals to y times 2y minus 1 times dx. Oh, sorry, dy. All right, so this is what I got over here. Okay, simply by multiplying y on both sides of the equations. All right, so at this point, why am I doing this step? You may ask me, why am I doing this step? Because, all right, what's the objective? The objective is to find the antiderivative or the integral of this infinite nested radical, okay, with respect to x. So if I'm going to integrate the whole thing, okay, or perform an antiderivative to it, now notice this entire chunk over here of nested radical, all right, is the same as y. Notice at the beginning of my solution, I actually equate it, let it be equals to y. So I can say that this is equals to the integral or the antiderivative of y with respect to x. Okay, I hope you can see what I mean here. So the next part, okay, so the next part is pretty simple. Now we have over here, okay, at the bottom, we have y with respect to x is equals to y of 2y minus 1 dy. So I'm just actually writing this entire part of the equation over here. Okay, I hope you can see what I mean. All right. And thus, I can perform an antiderivative of y with respect to y. Okay, first. So in this case, if I'm going to perform an antiderivative of y with respect to y, I simply get 2/3 of y to the power of 3 minus half y squared plus the arbitrary constant c. Okay, so what am I doing at this point is actually I'm performing something called the indefinite integral. I'm trying to find the function of the indefinite integral, and the solution to this function is 2/3 of y power of 3 minus half y to the power of 2 or y squared plus the arbitrary constant c. All right. So after that, after I found the indefinite integral or antiderivative, now I'm going to take a look. What happened? Look at the boundaries. Remember, in our question, we are given the boundary from 0 to 1. So in this case, okay, I'm going to see, let's take a look at the upper boundary, okay, which is 1. Because the lower boundary is 0, the upper boundary is 1. What happened? Okay, like what I have done previously in some of my videos on how to solve, okay, a nested radical, an equation involving nested radical, the procedure is the same thing. When it is 1, when x is equals to 1, bam, we have this quadratic equation. Why? Because I just simply square both sides, minus 1 and minus y, to equate it to 0. Thus, I form a quadratic function like this. And by solving it, okay, I simply got the golden ratio, which is 1. Okay, it can be plus minus root of 5 over 2. That is the golden ratio. And yeah, basically this entire nested radical terminates at, okay, the golden ratio. All right. Now the lower limit, which is 0. Okay, just now we have attempt 1. Now we attempt 0. What happened when we attempt 0? So when we attempt 0, same thing. But now it's very interesting. Now, when we are dealing with nested radical tending towards infinity, we have very interesting results. Okay, as you can know, see from my previous few videos, you will know what I mean. Okay, but what about 0? You may think that, hey, 0, the root of 0 is always 0. But is that true? Now, let's perform the same procedure. So with the same procedure, okay, all x is equal to 0 equals to something else. Let's call it y to be something else, okay? So simply, okay, I square both sides of the equation, minus 0 on both sides, okay, which is basically y squared equals to y. So y squared minus y is 0. Okay, so this is what you can derive. What is going to happen here? You have actually two solutions. One is either y to be equals to 0 or y equals to 1. Okay, simply, okay, you can just solve this equation over here and you have two solutions, 0 or 1. Okay, so now what is going on here? Now, this is to tell us that when x is equals to 0, the lower boundary, okay, there are two solutions. So it actually maps itself. When x is 0, it will maps itself under the function, okay, to 0 and 1, okay, for these two range, okay, over here. So when x is equals to 1, what happened? Okay, we have 1 plus root 5 over 2 or 1 minus root 5 over 2. Okay, so now we have actually two, okay, two solution. Okay, so from one domain we mapped into two, from one domain we map into two again, undergoing the function. So what's going to happen? Which one are we going to choose? Okay, so now we are either going to choose this or whatever. Now, which one to choose? Now, since if let's say, okay, for the sake of this argument, let's see that the root of 1 plus, root of 1 plus, root of 1 plus, so on and so forth. Okay, we are going to take this as a positive number. Okay, if this is a positive number, we are going to take simply 1 plus root 5 over 2, because 1 minus root 5 over 2 is negative. So thus, if I'm going to take this is a positive number, this is a negative number. So this is the lower boundary in this case. This is the upper boundary. So if I'm going to take the upper boundary, based on the first premise, I have to also take the upper boundary in this initial statement that I've gotten. So the two boundaries that we are taking is the integral between y is equals to 1 and y equals to 1 plus root of 5 over 2. All right. In order for this whole thing to make sense, okay, if and only if this is going to be positive number, okay, if this is positive number, we are going to take these two as our boundaries, okay, to perform the integral lah, basically, because this is in terms of y, so we have to take in terms of y over here. So that is also the reason why am I doing these steps over here, okay? So now we are going to write down the indefinite integral. Remember just now the indefinite integral that we have obtained, okay? So this is what we are going to use. Thus, the definite integral of the nested radical with respect to x between 0, the boundary of 0 to 1, okay, in terms of x, is equals to 2/3, okay, of the upper boundary. Remember, we are taking upper boundary, which is 1 plus root 5 over 2, okay, to the power of 3, minus half, okay, 1 plus root 5 over 2, because another y again, square, minus 2/3 of 1. Remember earlier we saw the boundary 1 or 0, right? Okay, so we are taking 1, the upper boundary. So 2/3 of 1 to the power of 3 minus half of 1 square. Okay, and the arbitrary constant is now gone because now we are taking definite integral. Okay, just now is just indefinite integral, now is definite integral. So if you know how to perform a definite integral, this is what you will get. Okay. Now, next step, very simple. We just simplify the expressions. Okay, over here, I can just write it down. Okay, I can just expand out, write it down. Okay, over here, same thing, 1 plus root 5 over 2 square. Okay, it will be 6 plus 2 root 5 over 4. Over here, 16 plus 8 root 5 over 8. Okay, if you just perform, okay, the expansion. Okay, so minus, in this case, 2/3 minus half, which is 1/6. All right, so, and in between is minus. Okay, so after that, we have simply 16 out of 3 of 2 plus root 5 over 8. Okay, basically how I get this, basically I can just take out, I factor out 8 and I just get rid of 8. Okay, and in this case, we have an 8 on top. So yeah, it multiply, it gives 16. Okay, so minus 3 root 5 over 4 over here, this whole thing, minus 1/6. Okay, so next will be 4 plus 2 root 5 over 3 minus 3 plus root 5 over 4. Okay, so this one is not changing. This one is not changing. It's only this because I'm just going to throw in the terms. Okay, basically just to cancel out 8 and 16 to get 4 and 2. All right. And finally, okay, by working through, okay, I just cross both sides. Okay, and I get 16 plus 8 root 5 minus 9 plus 3 root 5 over 12 minus 1/6. Okay, I just combine the two fractions. Thus, finally, I have 7 plus 5 root 5 over 12 minus 1/6. Okay, this whole chunk here will be 7 plus 5 root 5 over 12. Okay, and 1/6 remains as 1/6. So if I subtract them, I get none other than 5, 1 plus root 5 over 12. And that is our answer to this question. Okay, so the answer is 5 multiplied by 1 plus root 5 over 12. All right, now let's check our solution. Okay, so coming back, now I'm going to share where I got this question from. Over here, okay. Yeah, so it's on the Instagram channel, and okay, that's the question. Thus, okay, some of them, okay, yeah, this one got the same answer as me, 5 over 12, 1 plus root 5 is the same. Okay, and others also get, okay, another one, okay, you got 7 plus 5 root 5 over 12. Okay, in this case, okay, reason could be why, because you actually took one upper and one lower boundary during your integral. So I don't think, yes, is this case. All right. Okay, so for the rest of them, yeah, I think for this person, he got a minus. No, it's not minus, it's plus. Okay, because for the root of 1 plus root of 1 plus so on and so forth, we are taking the fact that it is a positive number. All right, so it's not negative number. Okay, and what about the rest? Okay, the rest also got, for example, this person, he also got 5 over 12 of 1 plus root 5. Okay, same answer as me. 5 plus 5 root 5 over 12 is the same thing. Just factor out the 5, you get that the same. The same. All right. No, not half. No, no. Okay, this one also got the same answer as me. Okay. Yep. So, okay, that's all for today. All right. Thank you very much for watching and have a nice evening ahead. Good night. Bye.